Ya, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ayesha Cindy Harifa, a doctoral student in Water Resources Engineering at University of Brawijaya. Today, I will present a journal review with the title of Land Cover Change Detection Near Small Water Bodies based on RGB UAV data. This paper was published in ISPRS Archive and investigated the potential of RGB UAV imagery for monitoring land cover change around small water bodies. In this presentation, I will discuss about the journal identity, introduction and background, knowledge gaps, research question and objective, material and method, result and discussion, and the last one is conclusion. This journal published in the International Archive of the Photogrammetry, Remote Sensing and Spatial Information Science, commonly known as ISPRS Archive. This paper is indexed in Scopus Quartile 2 and published on 30 May 2022 of a volume of 43 issue B3 to 20 and 22 years. For the pages is 617 until 623. The article title is Land Cover Change Detection Near Small Water Bodies based on RGB UAV data, the case study on Pond Borough, Czech Republic. The author is Czech, Komarkova and Sedlak from Faculty of Economic and Administration, University of Pardubic, Czech Republic. The study focused on detecting land cover changes using RGB UAV imagery and compare several machine learning classification methods, including maximum likelihood, support vector machine, random trees, and deep learning. The background of this article. Land cover monitoring has become increasingly important due to the rapid impact of human activities such as agriculture, urbanization, and deforestation. Traditionally, satellite imagery such as a Landsat has been widely used for land cover analysis. However, satellite data often lacks sufficient spatial resolution for detecting detailed changes in small area. Recent advantage in UAV technology provide a practical alternative. UAVs can capture very high resolution imagery at relatively low cost and can be developed whenever needed. One limitation of many low-cost UAVs is that they only carries RGB cameras and do not include near-infrared sensors. Making it impossible to calculate vegetation indicators such as NDVI. To overcome this limitation, the study used RGB based on vegetation indicators and machine learning technique to classify land cover detect changes over time. The research area is Ponpara, a protect conservation area in Czech Republic that experiences ecological changes after the introduction of wild horses for vegetation management. And next, why this topic is so matters. This topic is important for several reasons. First one, accurate land cover information support environmental protection and sustainable resources management. Secondly, small water bodies are often overlooked despite their importance as habitats, local water source, and flood mitigation zones. Third, UAV imagery provides extremely high spatial resolution, allowing researchers to observe detailed environmental changes that cannot be detected by most satellite systems. Furthermore, this study demonstrates that affordable RGB helps identify the most reliable approach for processing high-resolution UAV imagery. And the knowledge gap for the article. The author identified several gaps in previous studies. Most previous research focused on large scale monitoring using satellite imagery, while small water bodies receive limited attention. Many vegetation studies relied heavily on an IA data, and relatively few investigated RGB only UAV imagery. There was also a lack of the direct comparison among different classification methods using the same dataset. Additionally, most studies analyzed single data imagery did not investigate temporal changes using repeated UAV surveys. Another challenge was the salt and pepper effect associated with very high resolution imagery, which had not been truly evaluated. Finally, the impact of wildlife-based conservation management, such as grazing by wild horses, had not been extensively studied. And research question for this study, there are four statement and question. The first one is, uh, how can RGB UAV imagery detect land cover change near small water bodies? And the second, how do ML, SVM, random trees, and deep learning perform in RGB UAV image classification? And the third is, which classification method yield the highest accuracy for pond borough? And the last one is, what land cover changes occur at pond borough during August until December 2021. And the research objective for this article, the first one is for assess the capability of RGB UAV imagery for identifying land cover classes near small water bodies. And the second is evaluate the accuracy of ML, SVM, random trees, and deep learning on RGB UAV data. And the third is determine the best classification method based on kappa coefficient. And the last one is analyze temporal rain cover dynamic at pond Paroh across five observation period. This study was conducted at pond Paroh protected wetland areas of the approximately 30,000 square meters located near Portubic in the Czech Republic. And the researchers using DJI Mavic 2 Enterprise UAV equipped with an RGB camera. 5 UAV surveys was conducted between August until December 2021, and then flight were performed at altitude of 60 meters with 60% overlap, and orthophotos were generated using Pix4D software. The resulting imagery had an exceptionally high spatial resolution of 1.9 centimeters per pixel. 6 land cover classes were identified by water, green vegetation, wet vegetation, bare land, freshly cut vegetation. And for classification technique were evaluated by maximum likelihood method, support vector machine, random trees, and deep learning method. The classification result was evaluated using the kappa's coefficient. Deep learning achieved the highest accuracy with a kappa value of 0.74, and then support vector machine achieved 0.65, following by a random trees of at 0.62 and maximum likelihood at 0.61. The result indicates that deep learning is more effective in handling complex patterns with high-resolution UAV imagery. The temporal analysis also reveals seasonal variation in vegetation cover between August until December. One challenge encountered was the salt and pepper effect caused by extremely high image resolution. Although majority filtering was tested to reduce this noise, it was ultimately excluded because it did not sufficiently improve classification performance. Importantly, the study demonstrated that RGB imagery alone was capable of distinguish all six land cover categories. And for conclusion, based on findings, several conclusions can be drawn. First, RGB UAV imagery is sufficient for land cover classification around small water bodies, even without near-infrared information. Second, deep learning was the most effective classification approach, achieving the highest kappa coefficient of 0.74. Third, very high resolution imagery introduces classification challenges, particularly at salt and pepper effect. Four, repeated UAV surface successfully capture seasonal vegetation dynamic, demonstrating the feasibility of multi-temporal monitoring. And finally, affordable RGB UAV systems offer a practical solution for local-scale environmental monitoring and conservation management. In conclusion, the study highlights the strongest potential of RGB UAV technology combined with advanced classification technique for monitoring land cover changes in environmentally sensitive area. Thank you for your attention. I would be happy to answer any question for discuss the study furthermore. Thank you. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.